So I'm starting with slide number 30. So although the cryptography has a long and complex history, it wasn't until the 19th century that it developed anything more than ad hoc approaches to either encryption or cryptanalysis, the science of finding weakness in crypto systems. Understanding of cryptography at this time typically consisted of rules of thumbs, for example, Auguste Kirchhoff's cryptographic writing in the later 19th century. Actually, up till 19th century, whatsoever the techniques those were developed in cryptography or encryption were ad hoc. Ad hoc means constantly changing. They are not constant, they are not static, they are changing from time to time, right? But after 19th century, I mean, when advanced cryptography has been emerged, then there might be certain techniques are given, जो हम आगे चल के पढ़ेंगे, DAS and AES, data encryption standard, and then you have the advanced encryption standard. These were the latest techniques which are being used today in the field of cryptography. But right now, we might need to understand more regarding the history of cryptography, right? So in this particular slide, you may see the person. The name of that person was Edgar Allan Poe, used systematic method to solve ciphers in 1840s, right? In particular, he placed a notice of his abilities in the Philadelphia paper Alexandra's Weekly Express Messenger, inviting submission of ciphers of which he proceeded to solve almost all. So what he has done, he has written certain, not a research paper, some sort of weekly newspaper information he has written, and in that he has given the idea of his own cipher. He has solved certain sort of cipher and given certain techniques to solve that particular problem. That was in 1840s, right? And then his success created a public stir for some months. He later wrote an essay on methods of cryptography, which proved useful as an introduction for novice British cryptanalysts attempting to break German codes and ciphers during World War I, and a famous story, The Gold Bug, in which the cryptanalysis was a prominent element. Actually, one thing I would like to tell you, in World War One, the Admiralty Room 40 broke German naval code and played an important role in several naval engagements during the war, notably in detecting major German sorties into the North Sea that led to the battles of Dogger's Bank and Jutlands as the British fleet was sent out of intercept them. Now, actually, what happened in the World War II or World War One? What is going to be happen? That was between Germans and other allies like India. I mean to say that England, USA, and the other countries were at one side, and Germany was on another side, right? So what happened during that World War One? Actually, Germany has, I mean, German. I mean to say that peoples or the, I mean, those who were fighting that particular war, they have sent certain encrypted information on the way. I mean, military, German military has sent that particular information. On the way, that particular information is being intruded by the England army or the England military. They came to know that the German military is going to deploy their ships, I mean sea ships, at that particular location, and from that particular location they are going to launch an attack over England or over allies or like something like that. That was the story. And when they decipher that particular information that was being sent by the Germany military, they came to know about that whole story, and based on that particular decipherment they have launched a pre-attack on Germans and destroy all the things and have won that particular war. ठीक है जी. So this was the basic idea, or this was the basic advantage of cryptography during the old wars, or the, I mean, military peoples used to send and receive, send and receive the information regarding the by using encryption or like that, right? So this was one story. Then in 1917, Gilbert Vernam proposed a tally-type cipher in which a previously prepared key kept on paper tape is combined character by character with the plain text message to produce the cipher text. This led to the development of electromechanical devices as cipher mechanics. Okay, देखें ये हमारे पास है थ्योरी. आई मीन टू से द थ्योरी का मकसद ये है कि दिस वाज द हिस्ट्री, और हिस्ट्री को हम हिस्ट्री करके ही पढ़ेंगे, ठीक है. सो डोंट बी कंफ्यूज दैट कि जी कि ये हम हिस्ट्री है, ये दिस इज जस्ट द 1 or 2 चैप्टर्स दैट वी आर गोइंग टू कम. आई मीन आई वुड लाइक टू टेल यू. उसके बाद जो चीजें हमारी चलेंगी दैट वाज प्योरली टेक्निकल थिंग्स. आई मीन हाउ टू इम्प्लीमेंट सिक्योरिटी, हाउ टू डू क्रिप्टोग्राफी, पब्लिक की क्रिप्टोग्राफी, प्राइवेट की क्रिप्टोग्राफी, सिमेट्रिक एसिमेट्रिक, या फिर ये सारी चीजें, ठीक है. तो दोज वर these will be technical na, but right now this is just I mean to say the history. So you need to understand history in its own way. जैसे हम social Pakistan studies पढ़ते हैं या इस्लामियात पढ़ते हैं, in the same way we need to learn कि जी 1917 में क्या हुआ था और 1800 में क्या हुआ था, or something like that, right? So this is what you need to learn, right? So this led to the development of electromechanical devices as cipher machines. अब actually गिलबर्ट वर्नम ने 1917 के अंदर एक मशीन जनरेट की, मशीन बनाई, या उन्होंने एक ऐसा मैकेनिज्म बनाया जिसमें हमारे पास what we have, he is going to I mean to say that encrypt its data by using a key. I mean, key is something like a token which is going to be added with that particular data, and then that particular data would be sent over a network. Now, encrypted information, right? When that particular data is being received at the receiver's end, the receiver must have that particular key in order to decrypt that information, right? This idea was given by Gilbert Vernam in 1917. So, mathematical methods proliferated in the period prior to World War II, notably in William F. Fredman's application of statistical techniques to cryptanalysis and cipher development, and in Marian Regevich's initial break into the Germany Army's version of the Enigma system in 1932. ठीक है जी, तो ये आपके पास था. And by World War II, mechanical and electromechanical cipher machines were in wide use. Although where such machines were impractical, manual system continued in use. अब actually cipher machines हमारे पास generate की गई, जिसको हमने क्या कहा गया, Enigma. This was the Enigma machine was widely used by Nazis Germany. I mean Germany's military was called as Nazis in that particular time. Adolf Hitler की आर्मी को Nazis कहा जाता था. Its cryptanalysis by the Allies provided vital intelligence, right? This machine was used for the cryptography, cryptanalysis, and all these things, right? Light cipher machines used in the World War II included the British Typex and the American Sigaba. Both were electromechanical routers designed similar in spirit to the Enigma, albeit with major improvements. Neither is known to have been broken by anyone during the war. ठीक है जी, तो अमेरिकन ने क्या किया, ब्रिटिश ने टाइपेक्स को बनाया और अमेरिकन ने सिगाबा जनरेट की, आई मीन डिजाइन की. एंड दिस वाज अगेन व्हाट, द साइफर मशीन. साइफर मशीन्स आपके पास क्या होती हैं, जो आपके पास डेटा को इनक्रिप्ट करें. आई मीन इंफॉर्मेशन इज बीइंग इनक्रिप्टेड बाय दोस पर्टिकुलर मशीन. सो नोबडी इज गोइंग टू ब्रोक दोस पर्टिकुलर मशीन्स by the World War II. US troops in the field used the M209 and the still less secure M94 family machines. British agents initially used poem cipher. Memorized poems were the encryption-decryption keys, but later in the war they began to switch to one-time pad. Now, US troops were using the hashing algorithm, that is M209 and M94, that we will be learning in the next few lessons of our course. But right now you need to understand that a one-time pad was a mechanism, that was a hashing mechanism that was being generated first time by US troops in that particular time, right? What is one-time pad? We have to learn in our next few slides, not in slides, but in the next few lessons, right? That was a technique, one-time pad, right? Now this was a machine, Sigaba. Sigaba is described in US patent filed in 1944 but not issued until 2001. This was the innovation by US Army, and this was being used for the cipherment of the data, I mean encryption of the data, right? राइट जी। तो अब यहाँ तक हमने जो चीजें पढ़ी, दैट वाज टोटली अ क्लासिकल क्रिप्टोग्राफी। ठीक है जी। स्टार्टिंग फ्रॉम इजिप्शियन टू रोमन टू मेसोपोटामिया, ऑल दीज पीपल्स, एंड देन मुस्लिम हिस्ट्री जिसमें आपके पास अल किंदी आ गया और उसने बुक लिखी, एंड देन ही हैज डन मैनी थिंग्स, एंड polymorphic alphabet, then monomorphic alphabet, all these things were done. We have learned regarding the ciphers, we have learned regarding the cryptanalysis. I mean, there are many encryption techniques were designed, there are many cryptanalysis techniques were designed by different scientists, and that was the ad hoc technique. These were the ad hoc techniques, I mean to say that. Not nobody was I mean, nobody was saying that this one is the confirmed technique that might be used in the cryptography or encryption, but I mean that was totally a classical era in which multiple inventions has been done in the field of cryptography. But make sure that was not for the general public. That was very much clear. These inventions, all these things were only being used by the military organization, and mostly they are being used in the, I mean to say that, wars. I mean the wars that were being fought between different countries. I mean World War I, World War II में आपके पास बहुत ही generally ये चीजें use हुई थी. I mean cryptology or cryptanalysis or like that. So both cryptography and cryptanalysis, both are the two different things. Cryptography means you are going to encrypt something. Cryptanalysis means you are going to decrypt. The methods that are going to decrypt certain information have become far more mathematical since World War II. अब World War II के बाद आपके पास जो cryptography है ना, वो ज्यादा करके mathematically डिफाइन होने लगी. आई मीन मैथमेटिक्स का बहुत ज्यादा यूजेज हो गया. इवन सो इट हैज टेकन द वाइड अवेलेबिलिटी ऑफ कंप्यूटर्स एंड द इंटरनेट एज अ कम्युनिकेशन मीडियम to bring effective cryptography into common use by anyone other than national governments or similarly large enterprises. Now see, in classical cryptography कहीं पे भी कंप्यूटर का जिक्र आया? No. Nobody is using any type of computer, any type of internet in a classical cryptography. But as the computer has been invented, as the communication networks has been invented, as the internet is being invented, the technology evolves, then the cryptography has also been involved. So definitely the ciphers which are being generated by certain sort of mechanisms, they are very easy to be deciphered by high processing machines, because we do have a very powerful machines like supercomputers are available now. Very strong passwords, very strong sort of encryption can be decrypted within a few seconds nowadays. That's what I mean to say. जैसे जैसे आपके पास टेक्नोलॉजी बढ़ी है, तो डेफिनेटली आपके पास हैकिंग और क्रिप्टोग्राफी, ये सारी जो चीजें हैं, इनमें भी आपके पास डेफिनेटली न्यू एडवांसमेंट्स आई हैं. ठीक है. तो फॉर दैट रीजन the cryptography totally has been changed, or encryption, I mean to say that security जो आपके पास mechanisms है, they are totally being changed. I mean in the classical cryptography or classical sort of security, the security is only, or the cryptography is only for the military organization. But when we are talking about the modern cryptography, that security is for everyone. I mean for the general public also. Nowadays you people are using all these security features inside your computers, inside your communication and all that. So this was the major difference between the modern and the older cryptography, right? Shannon was the person who was the inventor of the new cryptography or the modern cryptography. The era of modern cryptography really begins with Claude Shannon, arguably the father of mathematical cryptography, with the work he did during World War II on communication security, right? In 1949, he published a communication theory of secrecy system in the Bell System Technical Journal, and a little later, the book, The Mathematical Theory of Communication, and both included results from his World War II book. So he has done certain research over a communication theory, how the things are being sent over a network or something like that, and based on that he has designed certain sort of standards or like that. So these standards we are going to learn in our next slide. So these, in addition to his other work on information and communication theory, established a solid theoretical basis for cryptography and also for much of cryptanalysis. And with that, cryptography more or less disappeared into a secret government communication organization such as NSA, GCHQ, and their equivalents elsewhere. So very little work again made public until the mid of 1970s, when everything changed. Now see, this is just the the evolvement of your advanced cryptography, that how it has been evolved, at what lab, what type of experiments were performed, but still that is not being make it that is not being public, right? Normal the general public was not able to utilize that particular techniques. Then the first encryption standard, that was called as the mid 1970s, saw two major public advances. अब यहाँ पे आके आपके पास दो मेजर इन्वेंशंस हुई, ठीक है जी, नॉन सीक्रेट एडवांसेस. फर्स्ट वाज द पब्लिकेशन ऑफ द ड्राफ्ट दैट इज कॉल्ड एज योर डेटा इंक्रिप्शन स्टैंडर्ड, दैट इज कॉल्ड एज योर DES in the US Federal Register on 17 March 1975. That was the first standard for encryption that was being invented in 1975, and this is for the general public. Now everyone can utilize, or everyone can use the security features that are being available over a network, right? So the proposed DES cipher was submitted by a research group at IBM. Everybody is very much familiar with the IBM company. At the invitation of the National Bureau of Standards, that is now are being called as NIST, right? In an effort to develop secure electronic communication facilities for business such as banks and other large financial organizations. Now actually, DES standard was designed for the peoples who are using or who are communicating between multiple organizations like banks, like large financial organization. They are communicating over a network and they want to secure their information. So DES was designed specifically for them. Now this is not for, military organization can utilize them, can use them, but this is not specifically for the military peoples that they can use it, no other people can use it, right? So that might not be the case. So after advice and modification by NSA acting behind the scenes, it was adopted and published as a Federal Information Processing Standard, that is called as FIPS, right? So DES was the first publicly accessible cipher to be blessed by a national agency such as NSA. The release of its specification by National Bureau of Standards stimulated an explosion of public and academic interest in cryptography. So this was the first publicly accessible cipher or standard that is being generated by NSA. The release of its specification by National Bureau of Standards stimulated an explosion of public and academic. By designing or by implementing DES in different organizations, it has stimulated the public interest, that everybody now, universities and different academic institutions, were also interested in cryptography and all these things. So they used to teach them. There are different courses were invented and people used to teach this particular subject in different institutions and something like that, right? So the aging DES was officially replaced by the Advanced Encryption Standard, right, in 2001 when NIST announced FIPS 197. After an open competition, NIST selected Rajendal, submitted by two Belgian cryptographers, to be the AES. Your DES was the initial cryptographic standard that was designed in 1975. But as the technology evolves, I have told you that it is very easy for the hackers or for the processing machines which are available nowadays. They can decipher the information that is being done by or that is being executed by the data encryption standard, right? So then a new standard was introduced, that is called as Advanced Encryption Standard in 2001. That was also being given by the NIST, and that the person who has given that particular to say that standard, that was Rajendal. We will be learning all these things in the future. So Rajendal was the name of the person who has given this particular standard, and that was the more advanced than your data encryption standard, right? Why it is advanced, what are the merits and demerits of DES, and what are the merits and demerits of advanced encryption standard, we shall be learning one by one in our future lectures, right? So regardless of dash inherent quality, the dash key size was 56 bits. अब यहाँ पे आके इशू आता है, आपके पास जो encryption होती है ना, वो 56 bit encryption होती है using dash, was thought to be too small by some even in 1976. अब 1976 में ये decide हो गया कि 56 bit encryption जो है ना, that is very weak encryption. I mean anybody can decipher the information that is being encrypted by the dash standards. So that is why perhaps the most publicly there was by Whitefold Daffy, there was suspicion that government organization even then had sufficient computing power to break dash messages. Clearly others have achieved this capability. I mean, many of the organizations have bought computers, and by combining the power of the computers, they can easily, I mean, break the encryption that is being implemented or that is being executed by the dash. That was the main reason that they have moved from dash to advanced encryption standard, right? And finally, we have the concept of public key. So the second development in 1976 was perhaps even more important, for it fundamentally changed the way crypto systems might work. This was the publication of the paper New Directions in Cryptography by Whitefield Daffy and Martin Hellman. It introduced a radically new method of distributing cryptographic keys, which went towards solving one of the fundamental problems of cryptography, key distribution, and has become known as Diffie-Hellman key exchange. The article also stimulated the almost immediate public development of a new class of enciphering algorithms, the asymmetric key algorithm. I mean, the public key cryptography is the same. You might have the key, and the person who only possesses that particular key can read or decrypt that particular information.